everybody. Welcome to OpenCV weekly webinar. And today we have a very exciting show for you. We are going to declare the winners of the OpenCV Spatial AI Competition 2022, sponsored by Intel and Microsoft Azure. And we have a part of the team that decided the winner. So let's go over all the people who are in here right now. I'll start with Brandon. Brandon, could you just have a small, brief introduction of yourself?
Yeah, hi everyone. I'm Brandon, the founder and CEO of Luxonis. We focus on making robotic perception cameras that make it easier for folks to ride this wave, this crazy computer vision, AI, spatial sensing, and robotic revolution that I think we're about to see. So I'm really excited to see all these entrants. It's so cool to see.
It's unlikely that people don't know you, Brandon, on this webinar, but just to give the full context, Oak Delight, on which this contest was based, is designed, built by Luxonis. And OpenCV collaborated with Luxonis to bring this product to the market. So kudos to you and your team for such an excellent product.
Thank you. Yeah, thanks for the proper intro too.
All right. Next with us is Anna. Anna, would you like to introduce yourself?
Yeah, sure. Thank you, Satya. So I'm Anna Petrovicheva. I'm the CTO of OpenCV AI and a part of OpenCV family. So I've been doing computer vision for probably like a very big part of my life, more than 11 years. So I'm also very excited to be here today, and also had a privilege to review the submissions from the first stage to the final stage. And I'm also like blown out by the quality of the work that the guys have done.
That's great. And just to complete the introduction, Anna is also the board member of OpenCV.org, the nonprofit foundation that actually manages the OpenCV library. And she also manages the developers from OpenCV.ai who help the OpenCV library. So, and with us also is Ye Lu. Ye, would you like to introduce yourself? Anna, you're frozen. I don't know whether it's me or your screen is frozen.
I can see you fine.
Yeah,
okay.
It looks fine to me. Anyway, my name's Ye, and I'm the CEO of Cortic Technology. So last year we entered the OpenCV Spatial AI Competition 2021, and we were fortunate enough to be the winner of the first place grand prize. So I think I know how much fun it is to participate in a competition like this, and after you complete the competition, you have this feeling that you have achieved a whole bunch of things that you wanted to do, but you didn't have time to do. So I hope that everybody that participated in this competition feel the same way as we do as well.
That's great. And, your submission last year was the cutest one, the most impressive one. You also won the competition. It was, and the best part was that you kept us entertained over the duration of the competition by giving giving preview of what you were doing. So that was a really, really good. Your team did a very good job, not only on the engineering side, but also on the entertainment side.
Thank you, Satya.
That's great. All right. And as always, with us is Phil Nelson, who is the content manager at OpenCV.org. And he did a lot of work for this competition. Kudos to you, Phil, for organizing this whole thing. You deserve all the credit for how smoothly things went. It's a lot of work. People don't realize, shipping things to different parts of the world, it's not trivial. And thanks a lot, Phil. Short introduction.
Yeah, hey everybody. Once again, it is I, the co-host with the co-most, the second banana who is second to none. I'm not middle-aged and crazy, I'm middle-aged and lazy, and I'm here to remind you about a couple of things we do every week here on OpenCV Weekly Webinar. First of all, we'll be taking Q&A from you all in the audience. Use the little Q&A button on the bottom of the Zoom window to ask your question at any time during the webinar, and we'll do our best to have time at the end to get to those questions. Also, we'll be doing a special 3-part giveaway here where you will be able to guess who our prize winners are and get not just a free Oak D Lite, but also $200 in Microsoft Azure credits if you're here in the Zoom audience only. If you're not in Zoom, hop on over to Zoom at opencv.live. Back to you,
HTTP. Yes. So yeah, thanks, Phil. Just to, I mean, in case people didn't get it, we will have 3 prizes. Each prize will consist of 2 things: an Oak D Lite plus 200 hours of Azure credit. All you have to do is, when we tell you, you have to guess who won the 3rd prize, the 2nd prize, and the 1st prize. And we'll show you the top 10, and then we will show you the videos for the top 5. And, we'll go from there. It's going to be very exciting. So Phil, it's your show now. You take over and show us walk us through all the competitors and the various submissions.
Yeah, definitely. So welcome everyone. We are, after the long 3-month build period, so happy to be able to announce the winners of OpenCV Spatial AI Contest brought to you by Intel and Microsoft Azure. So what is Spatial AI? For those of you that are maybe not familiar with what Oak is and what this contest was really about, simply put, Spatial AI is the ability of an AI system to reason based on what it's looking at and how far away things are. Here's a simple example of that. You can see the hand gets closer, and then we can actually measure the distance, not just in 2D, but in 3D. And what is Oak D Lite, the device that made this contest possible in the first place because it's so affordable and small and easy to use? It's a depth camera with AI power inside, a Myriad X chip, in fact. You may know it from the Kickstarter campaign last year, which raised over $1 million with almost 8,000 backers. Many of you are in the audience today. Thanks for supporting us all along. We had a bunch of countries represented in our submissions for the finalists here. We selected 50 teams, and here are all the regions that they were represented in. 50 Phase 1 winners, as I said there, and we're going to be choosing 3 grand prize winners today.
It started with 200 submissions,
Yes.
more than 200 submissions. I think it was 220 or something like that.
Yes.
People first sent the proposal, what they are going to do, what kind of robotic manufacturing application they're going to build with Lego sets and OpenCV AI kit. And 50 of those teams were selected, and from all those teams received one or more Oak D Lites, and they also received a Lego set. And using that, they built and sent the final submissions. And now we are down to, we have to select the top 3.
Some teams got very clever with their brick building. They were using, ad hoc kits that they had to kind of make themselves because of the supply chain issues, which everybody on this call is very aware of. But folks that maybe don't work in manufacturing at all don't know just how bad it's been. But the reason you can't find a lot of the stuff you want to buy lately is for the same reason that it was a lot of work for some teams to have to even redo their project spec because they couldn't physically get the gear they needed. And so they had to get very clever and kind of think on their feet, which was really, really cool to see these teams kind of take up that mantle and just run with it.
Can I ask one question to Brandon? Brandon, could you let us know how, we were in this middle of this, we started doing this competition, and right then the supply chain problems hit, but Oak D Lite delivery was not affected at all. How did you pull it off?
Yeah, thanks for asking. Must be kind of a plug for Luxonis. Yeah, we're just crazy people. So that's long story short. So when we saw this happening, we just, at the very early, we're the toilet paper hoarders, I guess. The chip shortage is now just the new toilet paper, if everyone remembers, from early 2020. So all the key components, we just bought a ton of them really early to make sure we'd be safe. And then, so that's one part of it. And then we've since consumed all of those. And so that helped to have supply. So we ended up being the only company of like all our competitors that didn't stock out during this period. So we had inventory the whole time. But then the other bit was just design. So when you look at, yeah, so Jason says we're the ones buying all the chips. That is true. So one of our
sorry, not sorry, Jason.
Yeah, but that's why they're oak delights for this, and you'll see the really cool things that were made with it. So unlike the other folks buying the chips are those that buy them and then mark a $1 chip up for $35. So we've seen our customers paying $35 for a $1 chip. We're making useful products and then getting them out to the world. So then the other bit is just the same thing that Tesla's doing. So Tesla is able to produce vehicles, which is for Oak Delight, we have 7 different designs. And so mid Kickstarter campaign, we had, I think, like 40,000 of one part arriving, and the manufacturer came to us and said, hey, we're only delivering 20,000. And so we went to several of our other designs. We had 6 others to choose from. And of those 6 designs for the PMIC, which is the power management IC, one of them had stock available. And so we were able to produce with that instead. So it's just constant triage and redesign is the other aspect, which is what I think it was like Forbes or one of the main ones was talking about. For companies handling the chip shortage, the main thing that these companies are missing is their engineering teams. Because if you can design around, then you can find a part that's in ample supply and it helps everyone, right? Because you're no longer buying the part that's, you know, stocked out and then someone absolutely needs. And some companies just can't do that. Automotive, generally you can't. Tesla's willing to kind of break the rules and just do things, and they end up with so much pain as a result. In this sort of solution, you know, no one cares in an Oak Delight what power management IC is in there, right? They just care that if it performs the same. And so if you look on the internals of these, that, you know, they'll look completely different, but have the same image sensors, have the same performance. So those are the 2 bits, you know, buying ourselves time by being really aggressive, really early on buying parts. That's too late to do that now, largely. And then just having the capability and willingness to put in a ton of long hours to redesign stuff. Sorry that was so long.
No, that's very instructive. You know, I also wanted to convey this to people that it's not easy. You know, that people would have spent, this thing could have easily been delayed by an entire year after the Kickstarter campaign, right? Yeah. If not for your good judgment and also the 6 designs that you could choose from. So those are very, you know, when you're designing engineering products, etc., it's not just about engineering, but it's also about the way you think about how you're going to deliver the product. So kudos to you.
Thanks. And you had to put perspective on that. The company, so Arrow, sent us the email that said your delivery date has, so this is during the Kickstarter, your delivery date has changed from October 13th to October 21st. And one of our engineers said, that's not a big deal. Like, kind of surprised to send an email, and just didn't notice that it, instead of 2021, it said 2023 at the end. and so, like, you know, had we not had the willingness to redesign things, like, it literally would have been a 2-year delay. And that's what you're seeing with a lot of companies that just say, you know, you can't buy these. Design is hard, right? And qualification's hard. And so it literally six-folds the work. Fortunately, we'd already done that. And so it's such a hilarious email to get, because it's so common now to get those that our supplier Arrow didn't even have to be like, sorry, your parts are 2 years late, right? They just changed the, you know, it was, you know, 13th to the 21st of the same month, and just changed the year by 2 years and didn't even mention anything. So I had to go to the engineer and be like, did I read that right? Did they say that our parts are now 2 years late? And he hadn't even noticed.
2 years and 4 days.
Yeah, exactly. Because it was so nonchalant, right?
Yeah.
So nonchalant email. Yeah.
All right. Let's keep moving.
Yeah. So our grand prize winner will win $5,000. Second place will win $2,000, and third place will win $1,000. There is another prize that we are announcing the opening of during this webinar. We'll get back to that in a minute. These top 10 teams were chosen. The top 3 were chosen by a cast of industry professionals, a couple of which are with us here on the show. We've got Anna and Gilles. Thanks for helping us out with this and bringing your expertise to the contest. Also, Murtaza Hassan, you may know from CV Zone on YouTube. Mariwa Olabella from Marvel, doing great stuff in the Tampa area. And of course, Gary Bradsky, the Chief Scientific Officer at OpenCV AI, and also, you know, one of the computer vision OGs here at OpenCV. The top 10 finalist teams got this little badge, as well as you'll notice there's a QR code on there. Congratulations to all these top 10 teams. These are the quality of these submissions were so high, and I think you know, part of that was due to the quality of the winning submissions last time, one of which was Team Cortic Tiger's proposal and submission. When people do great work and show other people, it raises the bar for everybody. And the bar was very high here for this top 10, so congratulations everybody that's listed here. You can vote for your favorite, who will win an extra prize from our sponsors. The voting will be open through Microsoft Build. You can go to opencv.org/OpenCV Spatial AI Contest, or just try to scan that QR code in the image, and you'll be able to vote for your favorite and enter yourself to win one of 5 free Oak D lights. Without further ado, unless anybody has any comments or questions here, we'll just start with the teams.
I just wanted to ask Anna and Ye about their overall thoughts on the submissions, and then we can move on to the top 5.
Sure.
Anna, would you like to go first?
Sure. So I'm a computer vision specialist, and I'm super far from the hardware part, the robotics part, but it's kind of still like super amazes me, like as if I was a child, right? So able to, you know, play with Lego design and design this, you know, thing that really works. I get like super excited. And the fact that these, you know, robotic things, they have computer vision on them and are doing some substantial, you know, have some substantial functionality. I think this is, you know, a combination of, you know, several things that basically get me excited. The quality of the final submissions was really high. And, you know, it's not the first Spatial AI competition, but it does not kind of cease to amaze me that, you know, different teams all around the world that are built of different people with different backgrounds, speaking different languages, they sit somewhere in their laboratories or their homes and build these things to participate in Spatial AI competition. So thank you, everybody, no matter are you in the top 10 finalists or not, for participation in the competition.
That's great. That's great. Ye, your thoughts?
Yeah. Well, as you know, we are Lego fanatics here at Cortic Technology, and it always amazes me to see so many different builds of the Lego robots and so many different ways for different teams to control how Lego works. And well, we know very well how much of a time sink it can be to design a Lego setup that works. And it's amazing to see that all 10 teams have done a fantastic job, and everybody has made something that can be potentially transformative for industrial automation. I'm just very impressed by all the submissions here.
Yes, and you know, in all honesty, your submission might have played a role in us coming up with this idea of using Legos for this competition, because in the last competition there was no requirement to use Legos or anything, but your submission, you know, it did affect our judgment.
They also shot down my suggestion to use Lincoln Logs.
Thank you. I'm very honored.
Great. All right, so let's go over the top 5 finalists.
Yeah, so we've got and Brandon, you got any thoughts on the top 10 here?
No, I think I was just gonna echo all the same things, and I was gonna bring up the same point with that I think you inspired all of this, because with your cute robot and all the capabilities, it was so fun to see. And then the only thing that came to mind is I was talking to some engineer and worked in a different field, and he was like, imagine if the quality of cement increased as quickly as the quality of all these AI and computer vision and robotics techniques, right? So it's just incredible to see the things that were, you know, that were produced in this time frame, right? Like these are systems that used to cost some of the things that we're about to watch here, like, were $1 million efforts on a production line over years and teams of engineers. And now you can just, still a ton of work went into it, but you can do it with not $1 million. So that's just so cool to see.
Yeah. I would like to add one more line is because I know the backgrounds of some of the people, some of the teams, we are not sharing the background in this webinar, but when they submitted the final PDF, they share what is their background. And a lot of those people did not have any background in AI or robotics, right? So they thought that, okay, these are the things available to them. What can they do? These are the capabilities of the camera. They didn't know how to train an AI model. They didn't know, how this Lego thing works, but they put together a team, they competed and they learned on the job, and they are in top 10, right? And the submissions are really high quality, right? The point I'm trying to make is that for the next competition, whenever it happens, don't be limited by, oh, I don't have experience. A lot of these people did not have experience either. And, you commit to something, you put your effort into it, good things happen. You'd be surprised how much you'll be able to achieve in a short period of time when there is a deadline and you're really passionate about something.
Absolutely. And oftentimes the best way to learn something is by doing it, and having a good reason to do it is, one of the things that makes these competitions fun, both for us and for the participants.
Yeah.
So yeah, let's, without further ado, I would like to say that the thing that was most interesting for me about this whole thing, viewing all of the submitted videos and everything, is the ingenuity and the different ways that people use the same sets, because a lot of these teams use the exact same Lego kit but built totally different systems with it, and it was really neat to see. So congratulations to all of you top 10 finalists. Top 10 in this contest is a big achievement. And of course, just to remind you, you can vote for your favorite at opencv.org.
Oh, there are prizes for voting also. Could you
That's
please?
Right. I already said it, man.
Okay, sorry.
You will win. You will be entering yourself to win one of 5 Oak D lights free of charge by voting for your favorite project.
All right.
So get to voting. Without further ado, we will be watching the videos for the top 5 teams and then revealing the 3rd place, 2nd place, and grand prize winners. Top 5 project, number 1, Team Potato Lovers with the Colorado Beetle Buster.
Hello all, I'm Marta.
And I'm Michał.
We are potato lovers.
Our goal was to significantly reduce the amount of insecticides used to protect potato fields.
And we would like to present you our project,
We do full
Colorado Beetle Buster.
I'm not sure
Our
if it's
solution
going to
based
screw
on
up
the Lego MVP, which provides us a vehicle with a
Google
robotic
Slides.
arm. Oak Delight camera is mounted on the top of the robot and provides us a Colorado beetle detection and deep image, which we use to calculate Colorado beetle coordinates. The center of the robot is the Raspberry Pi, which controls Oak D, Lego hub, and the spray gun. The spray gun is mounted on the top of the robotic arm and is supplied by the low-voltage water pump. The water pump is powered by the electronic circuit designed by us and controlled by Raspberry Pi.
I love any time we combine robots and water. I think this is one of the physically largest projects in the contest as well.
It's maybe a bit hard to see there, but the beetle has been found and it's highlighted in red.
Mm-hmm. Yes, and folks will be able to watch these videos on the voting page for your the top 10 as well.
And in case it wasn't visible, just a perfect small amount of liquid was sprayed directly on the beetle there.
Phil, if we click on the video, can it not go on YouTube and play it?
I don't want to screw up the Google Slides full screen thing.
All right,
I've seen it
all
go
right,
really.
all right,
I've seen it go
yes.
very wrong before.
No. And we also don't want to reveal the.
Exactly.
Just skip all the way to the end. Skip back. Show all the winners on accident.
Yes, that's.
We've got all 3 beetles there, which is super cool to see. And this can be so beneficial to the environment because you're no longer spraying the whole plant. Like maybe you're spraying 1% of what you would otherwise, or 0.1% because it's targeted.
Yeah. Any thoughts on this project before we move on?
I just love it. You know, when I was a kid, my grandma taught me to catch these bugs on the potato fields, and it was super tiring. I didn't like that. And also I don't like bugs. So I'm in love with this project.
That's great. All right. Project 2 in the top 5. Team Robotic Elephant with the CV-aided conveyor belt.
Hi, my name is Chris Nogic from Robotic Elephant, and I would like to present a LEGO Mindstorms conveyor belt operated with 2 Luxonis Oak Delight cameras. Let's see how it works.
Great sound effects on this video. I've seen this video 5 or 6 times, and I still smile every time.
You know who made it.
Another one of the very cool things here that was a little bit different than the previous contest is people made a lot of ad hoc UIs for control and monitoring, and it was really neat to see. So much personality. All right, thoughts on the computer vision aided conveyor belt?
I have one thought, not on the technology, but on the, you know, so we had several submissions which were very similar in, you know, there was a conveyor belt and there was an object classification. But the main thing about this is it boiled down to, you know, presentation, that among these various submissions, which were technically, they were about the same, but then how was the final result presented, right? So, you know, in competitions, if there is a tie, it will often be resolved by how you feel about the project, the presentation. So that's something I just wanted to point out, that this is a very good submission, but it was also similar to other submissions that we saw. And this stands out because of the excellent presentation.
Yeah, presentation matters. Thoughts, yeah, or Anna?
Yeah,
I also wanted to highlight the fact that this is a one-person team.
Oh yeah,
Yeah, I just want to echo what Satya said. when I looked at this submission at the beginning, the first thing that captivated me was the video. The video is really well done, and then it conveys exactly what the project wants to accomplish, and it does that really, really well. And then and then I get to read the project report again. It's really well done. Everything is laid out properly. All the technical stuff is laid out as well. It's a pleasure to watch the video and read the report. So I think this is what makes this project stand out from the rest of the other similar ones.
Yeah, presentation matters, and this was a very professionally presented project for sure. Brandon, thoughts?
Yeah, so it's it's easy to look at these and be like, oh, it's like a fun toy, but I actually got the opportunity to do kind of one of those like how it's made things, going to how onions are farmed, and same for oranges, and so there's this concept of a packing shed, which I'd never heard before, which is this but huge. Like it's exactly what you just saw, where they'll have onions or oranges or other things going down a conveyor belt. And then have whole teams of maybe 100 people that their entire job is to do exactly what you just saw, which is like, if it's okay, let it go forward. If there's a blemish, throw it in the trash. And so this may seem like it's a toy, but the capability of this in agriculture is astounding. And so the data they shared with me for onion farming alone is if you can put this on the onion harvester, right now, the way it works is you actually have conveyor belts on the onion harvester, and they don't have enough workers to be able to put workers on the onion harvester. And so a given harvester during harvest season takes 10 million pounds of onions, a given harvester. And a given farm in Idaho will have 10 of those running, right? So you're looking at, tens of millions of onions. About 10% of those are going to be bad. So on a given machine, you have 1 million pounds of onions that are bad. They get put on a truck every day and taken to a packing shed so that a person can take the bad onions and put them in the trash that then get trucked somewhere else, right? And so this sort of technology, you put that on an onion harvester or other harvesters. These are the ones where I got to see like how it's actually made, the whole process, right? So 1 million pounds of bad onions, the amount of CO2 that's released, the amount of vehicle maintenance, the amount of waste, and the fact that those bad onions are actually good for the soil. It'd be better to put them back in the soil. So this exact thing is what's needed on an onion harvester. And literally that like pushing mechanism, the way that it would be done on the onion harvester is exactly the same. It's just pneumatic air. So it literally shoots the onion back into the field is the process, but it's verbatim what you see here. So it's so cool to see that prototyped. And then the next stage of this is doing it with adult Legos, if you will, just big pieces of metal instead of relatively small pieces of plastic. So just wanted to share that perspective on it. It's going to help so much, reduce so much waste and pollution, and just so much food waste.
Yeah. Great project, great submission. All right, project 3. Team ICANN Reborn, Scan Nerf. You may remember them from an episode of OpenCV Weekly Webinar. Let's check out the video. Neural radiance fields have been getting a lot of press lately. You've probably seen people posting about them. And you'll notice this is the same Lego set as our previous video, just in a totally different configuration. Music's almost sinister. All right, excellent demo there. Satya, what do you think?
Well, I think it is one of those teams that that they know they have done a good job, and they're not even going to say a word about it, right?
Yep.
Just check out the demo.
The proof is in the pudding.
Yeah. shut up and watch the video, right? They did not say anything in the video. It's like, here's the demo.
Yeah.
I'm not going to say anything, right? So I loved it.
The confidence comes through in their project.
The confidence and the execution is awesome. This is non-trivial to do.
Absolutely.
And the video is awesome. They don't use a single word. They don't explain anything, and you know everything there is to know, right? So that's really solid execution. Not a word is spoken. Everything has been communicated.
Yeah, definitely. Brandon, thoughts?
Yeah, so apologies if I too excited about all these. So we, Luxonis got started because we were wanting to make safety systems. We were actually working in AR, VR, which is immediately applicable here. And then one of the founders in our area around Denver was actually struck by a distracted driver, not a bad person, just someone who was texting at the wrong time and killed him. It hit him just with the mirror in the back of the head and it killed him. And then a bunch of other technical folks. One got a traumatic brain injury, one of the top programmers in my network here. And so all of this came from wanting to build safety systems, which could be like, well, this is back to AR, VR. But interestingly, this is extremely valuable for safety systems as well. So when you're trying to validate these safety systems, and you're trying to keep people safe from machinery and so forth, one of the problems that comes up is like, how do you actually know where the thing is? Like, obviously, we're making a device that's trying to prevent like impacts of things and preventing, folks from walking into the wrong areas or riding bikes into the wrong areas. But how do you know that the safety system you've built is actually measuring correctly? And one of the really cool things about NERF technology is for a given scene, you can set up an array of cameras and literally reconstruct to 5 centimeter level accuracy where was everything, right? Where was literally everything in a given scene, so that you can know like a nearly perfect answer of that given test condition. And here it's shown with a robotic arm moving, and that's generating multiple images from multiple angles. But you can conversely set up a large environment where you have maybe 10 cameras in fixed locations to regenerate that whole scene. And we were talking about this before this episode started, that it's like what Steven Spielberg would spend $100 million on to have like a full 3D capture with accurate location of everything.
Just a few years ago, even, yeah.
Like maybe a decade ago, that cost $100 million and a huge, multi-year effort to make it happen. And now with, maybe a 10 OCD PoE, which is just the power of Ethernet, so it's easier to wire version of this, you can do the same thing using this NERF technology. So it's just, obviously in metaverse, AR, VR, this is extremely useful, but it actually transcends that and goes into these safety system applications too, and validation and test and so forth, that were otherwise kind of unsolved problems. You'd have to install a bunch of, $30,000 LiDARs, and still you don't even have this level of granularity. I'll stop there. It's super cool.
Yeah, no, it is super cool. It's easy to get caught up because of how cool so much of this is. Yeah, thoughts?
Yeah, well, we know the ICANN team really well because they participated in the 2021 OpenCV competition.
That's right.
And we know that they are very, very technically strong in computer vision and 3D reconstruction. So when they entered this contest, I was really looking forward to what they're going to do. And surely they didn't disappoint. And the combination of Lego and the NERF algorithm is just mind-blowingly good. And from the videos, just everything happens in real time. It's very, very impressive.
Absolutely. Anna?
Yeah, I wanted to second here saying that ICANN team did a really great job last year. They were one of the original winners and one of favorites of myself. So I was super surprised to see them doing something very comparable in terms of how it was executed, but very different from what they did the last time, right? It's a different project, not connected to, well, maybe slightly, but the idea is that ICANN Unicorns team seems to be super interested in the like 3D world, right? But this is the only link between their previous submission and their current submission, and both are super strong. So kudos to them.
Absolutely. Satya?
I already expressed my thoughts in the beginning.
Yeah, extremely cool. All right. let's move on to project 4 of the top 5. This is Team UCA Robotics, Vision-Based Human-Robot Interaction. For collaborative tasks, which is the really interesting part of this to me. So here you're sort of seeing that the robot won't even engage unless you're on the list of people that's allowed to be collaborating at this time, which is...
It's the Michael Scott forklift problem.
Yes.
To let Michael Scott drive the forklift.
Exactly. Making use of the spatial AI and machine learning power here. It's going to look so cool when this thing's 50 feet tall, isn't it? You can see on the right there, they're capturing volumetric video.
This is how you finally win that cup game.
Pick the red, get ahead. Pick the black, sit you back. Yes, this team definitely accomplished a lot with in a short amount of time. Quite a lot of work. Just a 3-person team. It's quite impressive. So that was project 4. Thoughts, Satya?
I was very impressed by this as well. They basically used everything, many aspects of the spatial AI camera, and the execution was great. You know, it may not be very clear, but they also had face recognition or face verification implemented in there. The robot will not operate until it is the right operator. And then, you know, all the demonstration was very good. Overall execution was superb, right? It is, and it's perfect. It is one of those projects that can be completed in 3 months, very, you know, and they kept adding more things to it and demonstrating what is capable, what are the different things capable of this. The planning was also good in my opinion, because it is one of those projects, even if they had completed, 2 out of 3 tasks that they had started doing, this would be a good submission, right? The competition, from a competition entry point of view, they had thought through, okay, these are the various things they are going to do. And even if they are not able to complete everything, it would be a solid submission. So I really liked it.
Yeah, definitely. Anna, thoughts?
Yeah, I super liked the comment, like before even we watched the video, that it would be super nice to see these things, but like 10 times larger. And yeah, I think this is kind of, for me, this is the right thing, the right way to think about this submission, right? It may be not super visible, the kind of the utility of this maybe not super visible at this scale, but it definitely is there when we think about industrial, for example, applications, agriculture, and other types of work that is like super hard to do for humans. So yeah, kudos to the team.
Definitely. Brandon, thoughts?
Yeah, so obviously it's super cool. And one of the things that might not be as clear on this is like the machine guarding aspect. So I made the Michael Scott forklift joke earlier. Forklifts can hurt a lot of people. They can hurt the operators. But more generally, there's with the robotic arm, a huge robotic arm, there's obviously the machine guarding aspect, which they've shown here, but there's all sorts of other equipment that, like, the equipment knows when it's dangerous and has some way to express that to the world, whether it's lights or buzzers or what have you. But it often doesn't know what the person is doing. And so the tricky part is there's a lot of machinery out there, a lot of heavy machinery that 99% of the time is perfectly safe, right? But if the human doesn't notice the light or doesn't notice a state or something like that, or is just sleepy, you can get killed really quickly with a lot of this heavy machinery. And I got another one of this is why I love working in these robotics and working on these cameras, is I've gotten to do the kind of like personal how it works things. And so I've gotten to go talk to folks who work in this heavy machinery environments. And one of them is dealing with like a moving tube that has, I won't get into the technicals, but it's like 200,000 foot-pounds of torque behind the rotating tube. And so the process is like, while it's rotating, don't grab it because nothing will stop it. But you can do your job faster if you like grab it while it's rotating. And so folks will do that. And one of the guys in that situation, he'd been doing that for like 7 years, even though it's against protocol, and his managers and everyone didn't know that that was the case. So there's no way to like prevent that effectively, because it's really hard even from a human from far away to know if the thing's rotating or not. And one day he had a burr on the tube. There was a burr on it, caught his glove, and it broke his arm in 68 places. And it would have killed him, but he had his safety harness on. It almost threw him like 60 feet to the ground. And so this is a perfect example of that machine guarding, is using this sort of technology. You can prevent workers from themselves where they do the wrong thing, right? And they get away with it long enough and then it kills them, or just save them from themselves when they're not trying to do the wrong thing, but they're putting themselves at risk and they don't know it. Because obviously the machine knows the state that it's in. With this 3D perception, you can know where the human is, where their hands are going. You can see from this, you can see who it is. So if it's Michael Scott trying to get access to the baler, it can prevent him from doing it. So it's for huge robotic arms, but it actually then goes across all these other industries of just general machine guarding of dangerous equipment, which are everywhere. Like our cars are produced with it, our laptops are produced with it, like everything in our day-to-day, and humans are exposed to that risk. So that's what this shows to me, which is really cool.
Yeah, definitely. Thoughts? Yay.
Yeah, this is definitely one of my favorite submissions, because to me, when you have an idea that you want to implement in an industrial setting, you don't necessarily go out and install it in a factory and get it to work. Obviously, you need to make some kind of proof of concept, and you can do that. And they've done that with Legos, and they've done that with the Luxonis OD light camera, which is very, very accessible, and you can prove out your idea. You can work out the potential problem before you migrate your solution into the factory. I think this is a great example of the prototyping capability of OD and Lego.
Absolutely.
One thing I meant to mention is, if you notice in the video, the robotic arm never dropped anything, but the human did. I think that's a testament to the solution. That was probably my favorite part of the video.
All right. The last of the top 5 projects before we announce the winners. Project 5 from Team Kiwi Bot Builders, the Agile Packer. One sensor to rule them all. This is another one of the bigger projects in terms of actual size. And using this Delta arm concept, which is very advanced. I just kind of want one of these to run in the background of my house. Just it's like a lava lamp. So cool. Shout out to Microsoft Azure. They used Azure Cloud Vision here for this project. One of the very cool things about this one in particular is they didn't just build the last mile infrastructure with the picker, they also built this process to generate the data they needed to classify. And of course, shout out to OpenVino. This was one of the things that was fun to watch on social media as some teams showed their proof of concepts or disproof of concepts in some cases for the early prototypes.
All right. So for this one, I think we should hold back commentary because we are hitting.
Yeah, we're getting up on time. Let's make our big announcements and get our giveaways.
Yes, I think we'll have to do that, unfortunately, but great project.
So the way our giveaways are going to work this week is you in the Zoom audience are going to guess who the third place winner is, and the first person to guess correctly in the chat here will win not just a free Oak D light, but also $200 worth of credit on Microsoft Azure, thanks to our sponsors. I'll give you all about 30 seconds to get your guesses in there, and we'll just go by who got it right first. Okay. Third place winner, Team Potato Lovers. Congratulations, the Colorado Beetle Buster, one of my favorite projects. Anytime you combine robotics and electronics with water, I'm going to want to see what happens. It's always funny. We will get in touch with the winner of our giveaway after the show here. So look for an email from me, phil@opencv.org. Next, the second place winner, same deal. I'm going to make a little note in the chat here. Got to remember which is which. All right, get your guesses in, folks. Okay, and the second place winner is Team UCA Robotics with their vision-based human-robot interaction system. Congratulations, Team UCA Robotics. Another extremely great project, very detailed, and a great submission in terms of the video and the PDF as well. And so our third prize, the grand prize winner. All right, everybody. Get your guesses in. This one's for all the marbles. This one's for $5,000.
But the more important thing is that all teams get to present their submissions at Microsoft Build. Unfortunately, it's going to be a virtual conference this year also, but it is still a very big platform for people to demo their what they have done.
It will be going out through all of Microsoft's channels, and it will be getting promotion from Intel, and it's a big honor. All right, the grand prize winner is Team ICANN Reborn with Scan Nerf. Congratulations, Team ICANN. This is, I don't know if this is the third contest they've entered here, but just consistently great projects from this team. They were on OpenCV Weekly Webinar, episode 46. Yes, congratulations.
Congratulations. That's really good.
The winners. Yeah. Incredible work from all of these teams. And as a reminder, you can go to opencv.org and vote for your favorite of the top 10 finalists. And by doing so, you will be entering yourself to win one of 5 free Oak D lights, but only if you vote. Voting will be open up through Microsoft Build. So get in there, encourage your friends to do it. I mean, you can only vote once, but that doesn't mean you can't have your friend vote for you.
Right. And one other thing I wanted to mention is that selecting these top 3 is actually very difficult. And, it's also subjective. You have to, at some point, make a decision because there are only 3 spots. And that is why we also have this popular vote. People can look at these submissions, and if they feel that, no, somebody else should have won, please cast your vote. This will also serve as a motivation to teams who participated and did not win, because these submissions are very, very close in their quality. We had a very hard time judging the top 3.
Yes, indeed. Yes, so congratulations to our winners. Going back briefly, do we want to say anything about Team Kiwi Bot Builder's Agile Packer system? We didn't get to do comments on that. We'll start with Satya.
Yeah, I really liked what they had built. It is, And I also like that they highlighted how many things failed, the various prototypes, etc. Because we get so used to seeing these, robotic arms working. We don't realize that these things are made out of Lego pieces, and there's a lot of design that goes into making them work. Something that is lifting, it's extremely difficult to make sure that it grabs the thing properly. You have to plan the approach. The conveyor belt is moving. You have to grab the thing properly and also design this arm properly so that it actually lifts. It is non-trivial to do all of these things.
Well, and there's pressure on the Lego bits as well to not just come undone.
So it's not the vision part, just the vision part, but also the robotics part using Lego pieces, which was very amazing.
Yeah, absolutely. Thoughts, Brandon?
Yeah, building stuff is hard. Just like
truth.
Echoing Satya's point, that it's like seeing the results of this, like there had, I'm just imagining, but unless it's there had to be so many late nights that went into this. I don't know how you do it, because you had like weekly versions in the last competition, but oh my gosh, just the amount of trials and tribulations to get something like this working. It's just in the amount of time that like you're just beating your head against something and then like questioning why you're doing this and why you try to make things. So I think it's just so incredibly cool. And not only do we have these awesome videos to look at, but then, the result of that work is it inspires other folks to say like, oh, like that's actually a doable thing, right? Like we can go do this. And so folks that, may never meet these teams will go off and do something great for the world. And then also on the flip side, these teams might end up in a place where they go do this directly. So it's so hard. And thank you for all the teams for, trudging through that. I know the late nights involved trying to make something actually work.
There's the long valley of, okay, we think we can do this to we have done it. It can be very demoralizing in between those 2 points, but
the valley of despair.
These teams, achieved despite that. Thoughts, Anna?
Yeah, this is incredible. Again, like the sheer thought of like teams working all around the world to make this happen is like incredible. So thank you, everybody. Thank you, the community. You're incredible.
Mm-hmm. Yeah, thoughts about Kiwi Bot Builder Agile Hacker?
Yeah, as Lego builders ourselves, we're just speechless about how they were able to build such a big Lego contraption and that worked really, really well. And not only that, they built the tool to capture the data as well. And you get to see the progression of the project. It's just mind-boggling about how much work they put into this. It's wonderful to see, and it's a great entry for sure.
Absolutely. All right, we're about 5 past the hour here. Last thoughts, Satya.
Thanks, everybody. Thanks, the judges and all the contestants. It was great. Last shout out to Anna, not just for this competition, but also for the previous competition, where she did a lot of work judging and everything.
A lot of that behind the scenes work, yes.
Behind the scenes work, which we never got a chance to acknowledge. Thanks, Anna. And also, please, we will announce the next competition sometime. It's an ongoing thing. Please contribute. Please participate. There, even if you think that you're not fully prepared, jump in and let's see. Give your best. Good things will happen.
You may surprise even yourself.
You will surprise yourself. So that's it. Thanks to our audience also. Thank you, everybody. We'll see you next week.
Yep.
All right.
Be careful. Thanks so much for watching this episode of the webinar. Please hit that like button, subscribe, and don't forget to tap the little bell icon to be notified when new episodes drop. This week's episode was brought to you by Intel and Microsoft Azure as part of OpenCV Spatial AI Contest. Follow along with the OakDLight Contest hashtag. If you'd like to be in the audience next week, subscribe to the OpenCV newsletter.